Students, this is just a little short introduction into Chapter 8. It's a review of imaginary numbers, some things that we covered in the last part of intermediate algebra. The notes you're looking at are notes that you can download from your My Math Lab course. They are my notes that you would have gotten in my class if we were continuing as usual for the rest of this semester. I'm going to give you a little time here to look at the way that you would get these notes. I think you already know, but this is a reminder. I've sent you this in an email already. Log into your course, click on Chapter Contents, choose Chapter 8, choose MacDowell Class Notes located at the top of the page. There's a link right beside it. Click on that link. Print out my notes for each section as we work through the rest of this course. In order to do your homework, go back to the main menu, click on Homework. Do that by following the same procedure you've always followed. To see these videos, evidently you already know or you wouldn't be watching this one, but it's YouTube, my name, Beth McDowell, and then whatever course you're in and whatever chapter. Back to Chapter 8. Remember that the square root of -1 is I, that I squared is -1, I cubed is -I, and I to the 4th is just 1. So, square root of -1 is I squared is -1, I cubed is I to the 4th is 1. Example, the way that you use this is the square root of -9 can be broken down into -1 times 9, which is 3i. Example B, the square root of -144 is 12i. Square root of -169 would be 13i. Complex numbers. If you got a real part and an imaginary part, it's called complex. 7 plus 2i is an example of a complex number. You can add these. 3i plus 7i is 10i. You can multiply them. 3i times 7i is 21i squared, which is -21, because that I squared, remember, is -1. You can divide them. 10i divided by 2 is 5i. We use these when we are simplifying negative expressions. Simplify. The square root of -28, you know you can break that down into -4 times 7. Square root of -4 is 2i. 2i times the square root of 7. Likewise, if you did the square root of -27, you would break that down into -9 times 3, which would be 3i times the square root of 3. That's just kind of a little review to get us started, but this real lesson 8.2 is about solving equations. It's about solving second-degree equations. We're going to do that with the quadratic formula. Even though I'm not giving you a test just on Chapter 8, these are important topics that we're covering, and you will need to know these in order to complete the rest of this course. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a is the quadratic formula. Before you're able to use the quadratic formula to solve something, you have to have that equation in proper form. Proper form is ax squared plus bx plus c equals 0. You have to have your equations in this form before you can use the quadratic formula, because you got to know what a and b and c are. Example, solve x squared minus 8x plus 15 equals 0. X squared minus 8x plus 15 equals 0. This is already in standard form, so all we got to do is substitute these values for a, b, and c into this quadratic formula. A equals 1, b equals negative 8, c equals 15. Substituting those values into the quadratic formula, we have the opposite of negative 8 plus or minus the square root of negative 8 squared minus 4 times 1 times 15 all over 2 times 1. Be sure that when you enter that in your calculator, you put parentheses around that negative 8. This is 8 plus or minus the square root of 64 minus 60 all over 2. 8 plus or minus the square root of 4 all over 2. That is 8 plus 2 divided by 2, and 8 minus 2 divided by 2. That gives me 5. That gives me 6 divided by 2, which is 3. When you get nice, neat, easy little answers like that, that tells you that you could have factored this problem to begin with. Our original problem was x squared minus 8x plus 15 equals 0. One way to solve is by using the quadratic formula. Another way to solve is by factoring. This would have factored into x minus 5 times x minus 3. Set each of those equal to 0, and you got x equals 5 or x equals 3. Same two answers. I don't know about you, but I would much rather factor if I can. I want you to make one little note. I want you to notice that we had a 4 under that square root symbol, and that we were able to factor this.